Good afternoon, dear students. Today we are going to discuss a new topic in a physical pharmaceutics, that is states of matter. So, what is mean by the matter? Which are the different states of the matter? And with respect to the individual state, we will discuss this all points in a detail. So, first important point is matter. In short, what is mean by matter? Matter means any object which occupy a certain space. Any object which occupy the space is known as matter. And this matter is exist in a three different states. Which are the three different states? First is solid, next is liquid, and third is gas state. Solid, liquid, and gas. These are three different states of the matter. So, what is the basic difference between these three states? The difference is with respect to the arrangement of the molecule. These three states of matter are different with respect to the arrangement of the molecule. How molecules are arranged in the particular state, and based on that, the which state the particular molecule are in, that is covered. Now we will see what is the exact difference between the solid, liquid, and gas. We will see with the help of example. We will see the example of water molecule. So water molecule, these molecules are exist in a three different states. Which are the three different states? The first is solid state, next is liquid state, and third is gas state. These are three different states. So solid state of H2O molecules is known as ice, liquid state is known as water, and gas state is known as water vapor. Okay. Now we'll see with the help of diagram. These are water molecules in solid state. You can see these molecules are very close to each other. They are tightly bound with each other, and that's why solids have specific geometrical shape. Liquid molecules are also close to each other. However, these molecules are mobile in nature. These molecules can flow in the direction of inclined surface, whereas if you see the gas molecules, these are quite apart from each other. Now we will compare these three different states with respect to the different points. The first is the distance between two molecules. You can see here these molecules, solid molecules are very close to each other. Very negligible distance is present. So very much less distance is present between the two molecules in solid state. In case of gas, it is quite intermediate. Actually, in gas also, molecules are close to each other, but compared to solid, the distances exist. And in in case of liquid, the distances exist. Whereas in case of gas, the distance is very much more. So these molecules are far apart from each other. In case of gas, you can see the quite more distance is present between two molecules, and that's why these molecules are far apart from each other. Now, next important thing, why the solid molecules are very close to each other. Molecules in a solid state are very close to each other, and why the molecules in a gas state are quite apart from each other. The reason behind this thing we will discuss with respect to the force of attraction. In case of solid, the force of attraction between the molecule is maximum. A maximum force of attraction between these molecules takes place. And due to maximum force of attraction, these molecules are very close to each other, and these molecules are very compact. These molecules are compact in compact arrangement. Whereas in case of liquid, it is intermediate again. Whereas in case of gas, a very much less intermolecular force of attraction is there. And due to less intermolecular force of attraction, the gas molecules are wide apart from each other. Means in short, the intermolecular force of attraction between the gas molecule like this is not sufficient to hold these all molecules together, and that's why gas molecules are wide apart from each other. You can see the distance between the molecule, it is more, whereas in case of solid the arrangement is compact arrangement. What is the reason? Reason is the strong intermolecular force of attraction. Next important thing, as you know very well, solids have specific geometrical shape. These molecules are immobile in nature. Why? Because they have very less kinetic energy. Whereas in case of gas, the kinetic energy is maximum. These molecules have more kinetic energy, and due to the more kinetic energy, these molecules are wide apart from each other. And next important thing, kinetic energy. Kinetic energy means what? Kinetic energy is nothing but a energy of motion. So due to more kinetic energy, you can see here, these are widely distributed, wide apart from each other. These are gas molecules. So due to more kinetic energy, these molecules are wide apart from each other. So you can see the distance, and distance between two molecules is very much more. And next important thing, due to more kinetic energy, these molecules are in continuous motion like this. According to collision theory, you can see these molecules are in continuous motion. These molecules continuously move. So suppose if I place a gas in a closed vessel, then what will happen? Suppose I have taken the gas in one closed vessel. This is one closed vessel and I have filled a gas. So these are the gas molecules. So these gas molecules are in continuous motion like this. So during this motion, we will see one molecule here. Now this molecule originally at this place. Now this molecule has moved from here to here, and this molecule has strike on the walls of container. So upon collision with the inner wall of container, molecule changes direction. Sometime what happen? The molecule, two molecules may collide with each other like this. Now this molecule has collided on each other, this molecule, and results in a change in the direction. The direction of both molecules will change. So due to more kinetic energy, these molecules are in continuous motion, and that's why gas molecules are mobile in nature. Why gas molecules are mobile in nature? Why? Because the reason is more kinetic energy. Next. Now what is the difference between solid, liquid and gas that we have basically discussed in short? Now how these molecules are converted from one state to another state. Let's say I have a solid state like this, then I have liquid molecules, and then I have gas molecules like this. As we discussed earlier, solids, in solids molecules are very close to each other. These are immobile in nature because they have very less kinetic energy. Whereas in case of liquid, liquid molecules are mobile. They can slide over each other in the form of layers. Whereas in case of gas, these are wide apart from each other. So solid convert into liquid. How solid convert into liquid? And liquid also can convert into gas, solid. Reversible conversion. So solid convert into liquid on heating, basically the process known as fusion. If you heat solid molecule, what will happen? The intermolecular force of attraction will reduce and results in a molecule will separate from each other. Liquid convert into solid on cooling. If you cool the liquid molecules, what will happen? Molecule lose its kinetic energy and convert into solid. The process known as freezing. Next, liquid can convert into gas. Liquid molecules can convert into gas molecule. Similarly, gas molecule can convert into liquid also. So liquid convert into gas, the process known as vaporization. Process known as vaporization. On heating, liquid can convert into gas because if you heat the liquid, the kinetic energy of liquid molecule increase and liquid will convert into gas molecules, highly energetic molecules. If you cool the gas, what will happen? The process known as condensation. So here the gas molecule lose its kinetic energy on cooling. On cooling, what will happen? Gas lose its kinetic energy and convert into less energetic liquid molecules. Next, solid can also convert into gas directly. Solid can also convert into gas directly. Solid molecules can convert into gas molecule directly by a process known as sublimation. Sublimation. So this sublimation process bypass the liquid state where solid can directly convert into gas. Generally what happens, solid convert into liquid, then liquid convert into gas. But in sublimation process, solid can directly convert into gas bypassing liquid state, and gas can convert into solid by a process known as deposition. So these three states, one are interconvertible, means solid converted liquid, liquid converted solid. Reversible conversion between these states takes place. So basically, how the conversion takes place? Conversion it takes place either by heating or cooling. Means in short, what happens? Just by increasing energy, kinetic energy, or by reducing kinetic energy. Solid can convert into liquid, liquid can convert into gas. Similarly, gas can convert into liquid and liquid can convert into solid either by heating or cooling. Now, how could you remember when heating is required, when cooling is required? This is totally based on the kinetic energy associated with molecule. Basically, solids, as we discussed earlier, it has less kinetic energy. Liquid has quite more kinetic energy, and gas has maximum kinetic energy, and that's why on heating solid convert into liquid, kinetic energy increase. On heating of liquid, liquid convert into gas, again kinetic energy increase. And the back conversion means on cooling, the kinetic energy, on cooling what happens, kinetic energy reduce. So on cooling of gas, gas loses kinetic energy and gas molecule convert into less energetic liquid molecule. Again, if you cool the liquid, what will happen? The liquid loses kinetic energy and liquid convert into solid. So this is just a concept of energy simply. So solid convert into liquid, liquid convert into gas just by providing the heat, means by providing the kinetic energy. Next we will see with respect to the gas state. Now we will see the gas state in detail. So far what we have discussed? We have discussed gas molecules. The most important thing, gas molecules are mobile in nature, means these are in continuous motion. So these molecules are in continuous motion, means these are continuously moving. Why? Because they have more kinetic energy. Kinetic energy of gas is more, and due to more kinetic energy, these molecules are mobile in nature. This is basic thing. Now next important thing, the force of attraction between the gas molecule. The intermolecular force of attraction is very less, and due to less intermolecular force of attraction, these molecules are wide apart from each other, means the distance between the two molecules is more compared to solid and liquid. So far we have discussed about these important points about the gas state. Next important thing, if you compare the volume of solid, liquid and gas occupy more volume. Why more volume? Because of very much less intermolecular force of attraction. The gas occupy more volume. So due to less intermolecular force of attraction, the gas molecules are wide apart from each other like this. Distance between two molecules is more, and that's why volume is more. And as volume is more, the density is less. So density, how we will calculate? Density is equal to mass per unit volume. So volume of gas is more, so density of gas is less compared to liquid and solid. Next important thing, the volume occupied by the gas. So as we discussed earlier, gas molecules are far apart from each other. So suppose I have packed the gas in a container, closed vessel, which has a capacity V is equal to 0.01 meter cube. This is the capacity of container in which I have packed the gas. Suppose I have packed the gas in this container, automatically what will happen? Gas molecules are widely distributed, so occupy the entire container. So automatically the volume of gas is equal to volume of container. Why? Because these are free to move. But if you check the actual volume of the gas molecule, the actual volume is less. So now how many molecules I have drawn here? 1, 2, 3, 4, 5, 6, 7. So actual volume of these 7 molecules is very less. This is volume occupied by the gas molecule and this is actual volume. So why gas molecule occupy more volume? The reason is only one important thing, that is very less intermolecular force of attraction. The force of attraction between the two molecules force of attraction between the two molecules is very less. And due to less force of attraction, these molecules are wide apart from each other. And why molecules are in continuous motion? Because of more kinetic energy. So gas laws better we discuss the relationship between the four major parameters. Which are the four major parameters? The first is volume of the gas. Next is pressure apply on the gas. Next is temperature of the gas. And last is number of moles. These are four parameters which are studied in the various gas laws. What is the relationship between the volume, pressure, temperature and number of moles? Number of moles means not a number of molecule. Number of moles you can calculate by using simple formula. Number of moles is equal to weight of gas divided by molecular weight of gas. So number of mole and molecular weight, these are two different terms. Number of moles you can calculate by using this formula, weight of gas divided by molecular weight. How much weight of gas we have taken divided by molecular weight, you will get how much number of moles of gas present. So these gas laws, the relationship between volume, temperature, pressure and number of moles were studied by different scientists. Many scientists attempted to study the relationship between these four parameters in 17th and 18th century. In 17th and 18th century, many scientists attempted to check or find out the relationship between these parameters. So these four parameters were studied by different scientists and find out the relationship results in a generation of three different gas laws, three basic gas laws that we are going to discuss today. So first gas law is Boyle's law. Next is Charles law. Next is Avogadro's law. These three laws we will discuss because these are mentioned in your syllabus. Boyle's law, Charles law, Avogadro's law. These three laws are combined to get one more equation which is known as ideal gas equation. One by one we will discuss. Boyle's law was the first law. Later on Charles law came into exist and later on Avogadro's law where came into picture. One by one we will see. So first law is Boyle's law. First law is Boyle's law. Boyle's law put forwarded by scientist Robert Boyle in year 1660. Boyle's law studied the relationship between two parameters, pressure applied on the gas and volume occupied by the gas. Now remember, you can easily remember these all gas laws by simply keeping one important thing in your mind, that is we have to discuss the relationship between four parameters, pressure, temperature, volume and number of moles. P means pressure, T means temperature, V means volume and small n means number of moles. In Boyle's law, pressure and volume relationship has been studied. So remaining two parameters means temperature and number of moles must be constant. Constant means same. So pressure and volume relationship has been studied here in Boyle's law. So which parameters are constant? Remaining two parameters. First is temperature and next is number of moles. These two parameters are constant. So according to Boyle's law, statement is very much simple. At constant temperature means at same temperature, at same number of moles, the volume occupied by the gas is inversely proportional to apply pressure. Means so short, the volume is inversely proportional to pressure means what? If you increase the pressure apply on the gas, the volume occupied by the gas will reduce. This is the relationship. If you remove the proportionality sign, V is equal to small k into 1 divided by P. In short, Vp is equal to K. This is the equation of Boyle's law. So, pressure is inversely proportional to volume, or volume is inversely proportional to pressure means what? If you increase the pressure on the gas, the volume occupied by the gas will reduce. Now, why such relationship has been observed and why the volume and pressure are inversely proportional to each other, that we will discuss with the help of diagram. So I will draw two representative diagrams here. Constant temperature and number of moles. So suppose volume occupied by the gas V is equal to 0.01 meter 0.01 meter cube, and the applied pressure is 1 atmospheric pressure. If you double the pressure, means I have increased the pressure. Initially pressure was 1 atmospheric pressure, now pressure is 2 atmospheric pressure. Then automatically volume will reduce. According to Boyle's law, the volume becomes 0.005 meter cube. So if you increase the pressure on the gas, automatically volume will reduce. And temperatures are constant. Means in short, what has happened here? Here the pressure is less pressure, and volume is more volume, and here pressure has increased, so more pressure and volume is less. So why such relationship has been observed, that we will discuss. On increasing pressure, the volume is reduced. So why such relationship is observed, that we will see. At less pressure, here you can see the gas molecules are wide apart from each other. Just check the distance between the molecules. The distance between two molecules is more. This is at less pressure and volume is 0.01 meter cube. If you apply the pressure, means if you increase the pressure, what will happen? If you apply the pressure, these molecules come close with each other like this, and just check the distance between two molecules. Distance is less. Means simply what has happened? Number of molecules are same, just molecules come close to each other, and that's why the volume of gas is has reduced. Means volume of the gas reduced means what happens? Just molecules come close to each other. So there molecules are at low pressure, molecules are apart from each other, and here molecules are close with each other. Means in short, on increasing pressure, what will happen? See, if you increase the pressure, what will happen? If you increase the pressure, if I apply more and more pressure, then what will happen? If I apply the pressure, what will happen? Here molecules come close. If I increase the pressure, molecules come close, and if molecules come close with each other, the volume of the gas, what is the effect on volume? Volume of gas reduce. This is simply effect has been observed in Boyle's law. Now with the help of graphical mean also you can explain the Boyle's law. If I plot the graph, 1 divided by P on x-axis and volume on y-axis, the graph will be like this. Means when the pressure is more, the volume is less, and when the pressure is less here, pressure is less, the volume is more. You can see here. Here 1 divided by P is more. 1 divided by P is more. At this point, 1 divided by P is more. But this is 1 divided by P. So pressure is less. Then volume is more. 1 divided by P is more. Means in short what happened? The pressure is less because pressure is at denominator. Pressure is at denominator. If denominator value is less, automatically the 1 divided by P will be more. One more graph we will see. Pressure and volume relationship. Directly we can plot the graph. Pressure on y-axis, x-axis, volume on y-axis. We will get a hyperbola. At more pressure, here you can see volume is less, and at less pressure you can see here the volume is more. Means in short, volume is inversely proportional to pressure. This is Boyle's law. Next law is Charles law. Charles law studied the relationship between two different parameters. Charles law was forwarded by scientist Jacques Charles in year 1787. He studied the relationship between volume occupied by the gas and temperature of the gas. So, pressure, volume, temperature, and number of moles. These are 4 parameters. In Charles law, volume and temperature relationship has been studied. So, remaining parameters is pressure and number of moles are constant. So, which are the constant parameter? Constant parameters are pressure and number of moles. According to Charles law, at constant pressure and number of moles, the volume occupied by the gas is directly proportional to temperature. Means if you increase the temperature of the gas, the volume will also increase. This is simple relationship between the volume and temperature. If you remove the proportionality sign, the V is equal to K into T. This is the equation of Charles law. Means as the temperature of gas increase, the volume of gas is also increase. With the help of diagram, we can study the Charles law. How the volume is increased on increasing temperature, that we will discuss with the help of diagram. In case of Charles law, the volume temperature relationship has been studied and both are directly proportional according to Charles law. So how the volume is increased on increasing temperature, that we will see with the help of diagram. Again, I will draw 2 different diagrams here. Initially, the volume is suppose 0.005 meter cube. If I heat this gas, suppose on heating means if I increase the temperature of the gas, what will happen? The volume is increased to let's say 0.01 meter cube. Means what? At less temperature, volume is also less, and on heating temperature is increase, so volume is also increase. Similarly, if I cool this gas, on cooling, reversible, on cooling what will happen? The temperature is reduced, so automatically volume is also reduced. So why the volume is increased on increasing temperature, that we will see. At low temperature and at high temperature, what is the difference? Here temperature is less, that's why volume is less, means these molecules are quite close with each other. Can check the distance between the two molecules. Molecules are quite close with each other. As the temperature increase, molecules move apart from each other. Distance between the molecules is increased. So just focus on the distance between the molecules. At less temperature, distance is less. At more temperature, distance is more. So on heating, what will happen? On heating, what will happen? The distance between two molecules is increased. Means these molecules move apart from each other. At less temperature, the energy of the molecules is also less. Here you can see why these molecules are close with each other, because here energy is less, and on heating we are providing the external energy, so here energy is increase. This is what happened. Means on heating molecules move apart from each other and results in increasing volume of the gas. This is Charles law. Next is Avogadro's law. Avogadro's law studied the relationship between volume and number of moles. And constant parameter are, now you can better way understand, because already we have discussed two laws, pressure and which is the next parameter, temperature. These are two constant parameters. Pressure is constant and temperature is constant. So according to Avogadro's law, the volume occupied by the gas is directly proportional to number of moles. Means in short what happens? If we increase number of moles, the volume occupied by the gas is also increased. The number of moles we have already discussed how we will calculate number of moles. Number of moles you can calculate by using this formula, weight of gas divided by molecular weight of gas. So how you can increase the number of moles? By increasing numerator, by increasing weight of gas. Means just we have to add more and more gas. So if you increase the weight of gas, automatically number of moles also increase. And if you increase number of moles, then according to Avogadro's law, the volume also increase. So on increasing number of moles, the volume of gas increase. Why? Because we are increasing weight of gas, means we are adding more and more gas. We will see with the help of diagram. Here you can see the volume occupied by the gas in first diagram. The volume is 0.005 meter cube, and in if you add the gas, what will happen? The volume is increased. Volume is 0.01 meter cube. Means in short, the volume has increased. So here the number of moles are less, and that's why volume is also less. Here number of moles are more. That's why volume is also more. This is simply Avogadro's law. Now, based on these three laws, just we will quickly summarize all three laws. First is Boyle's law. According to Boyle's law, the volume is inversely proportional to pressure. According to Charles' law, volume occupied by the gas is directly proportional to temperature. And according to Avogadro's law, volume is directly proportional to number of moles. So left hand side of all three relationships are same. So if you combine these three, you will get volume is directly proportional to 1 divided by P into T into N. If you remove the proportionality sign, V is equal to R into 1 divided by P into T into N. Again, if you make a rearrangement, PV is equal to nRT. This is your ideal gas equation. So what do you mean by R? R is a gas constant. This equation is known as ideal gas equation, which is also known as universal gas equation. So what we have discussed, ideal gas equation, or which is also known as universal gas equation, is equal to PV is equal to nRT. Those gas molecules which obeys this ideal gas equation are known as ideal gases. Gas obeys the ideal gas equation means, in short, what happens? Ideal gas equation is derived from three laws: Boyle's law, Charles' law, and Avogadro's law. So molecules of the gas obeys ideal gas equation means what? Molecules of the gas obeys these three laws. So if gas molecule obeys these three laws, the gas is known as ideal gas, and if gas does not obey the ideal gas equation, then these gases are known as real gases. So what we have discussed so far, we have discussed the basic difference between solid, liquid, and gas. Then we have discussed gas laws. Three different gas laws we have covered, and one ideal gas equation we have covered. Ideal gas equation also we have covered in this lecture. Next lecture we will cover the Andre's isotherm and liquefaction of gases. Thank you.